All right, I was going to say good morning, but I think we've officially crossed the threshold into afternoon. So good afternoon, everyone. Thank you for being here. Welcome to Untangling Terraform through Refactoring. I'm Nell Shamrell-Harrington, and I'm an engineer at Chef. You can feel free to tweet me at @NellShamrell or email me at nshamrell@chef.io. Now, in my work at Chef, I have refactored a lot of infrastructure code, including Terraform code. And I love Terraform. One of the things I like to say is that using Terraform makes me feel like Elsa from the movie Frozen. I just go shoom, and I have an infrastructure cluster set up, or shoom, and I have the other infrastructure cluster set up. Now the problem is when I'm changing my Terraform config, particularly when I already have infrastructure that's running on it, it can go just as wrong as the ice magic does in that movie. So this talk will teach you how to refactor your Terraform code in a careful way with minimal risk. Whoops. So first let's talk about why you might find yourself wanting to refactor your code. You may need to add a feature, and that's impossible with the code in the state it's in currently. You might need to fix a bug. You might need to improve the design of the code to make it easier to work with. This is often, whenever I come to a new job, I immediately get that itch to redesign the code to make it easier to work with. Or you might need to optimize resource usage, such as CPU, memory, disk space, or in the case of this talk, Amazon Web Services resources. Now, it would be one thing for me to tell you how to refactor, but in this talk, I'd like to take you through a real-life example. In fact, spoiler alert, this example is the first Terraform config I ever wrote. And it's called Supermarket Terraform. If you'd like, you can check out the original source code at github.com/nellshamrell/supermarket-terraform. And I will tweet that out after this presentation. Now, when I refactor code, whether it's application code or infrastructure code, I like to start out by mapping out the major components of the code in a visual way. So first of all, our main Terraform config file lives in this file called supermarketcluster.tf. And this file needs to use certain variables when spinning up infrastructure. If I'm spinning up my infrastructure in AWS, I need to include things like my AWS access key and my AWS secret key to get it spun up in the correct account. And I define these variables in a file called variables.tf. And then I provide the value for these variables in a file called terraform.tfvars. This is a lot of the default names for these files. So these three files are the core files of my Terraform config. Now, before I continue, some of you who have worked with Terraform, in particular with Terraform with AWS, might be asking, why am I passing my AWS credentials in line rather than using a credentials file on my workstation and passing them in that way? And the answer to that is you certainly can use a credentials file when using AWS with Terraform. But for the sake of this example and the sake of this presentation, we're going to go ahead and pass them in line. So let's take a closer look at supermarketcluster.tf. Now, this file has way more code than I can show on one slide. It's over 300 lines. So instead of showing that code, let's go through a visual representation of what the code does. So when I run Terraform apply from my workstation while using this config, I expect that it's going to spin up an AWS security group, then add a rule to that security group that allows SSH access into my instances, followed by a second security group, which adds a rule to allow traffic to flow from within my instances to the outside internet. Then it creates an EC2 instance and configures that instance to be a Chef server. And then it configures a second EC2 instance and configures it to be a supermarket server. So Supermarket is another Chef product that can be used in conjunction with a Chef server. It provides an easy-to-navigate artifact repository for sharing Chef cookbooks and tools. So it's then going to configure that supermarket server to use the Chef server for authentication and authorization. And then it will configure the Chef server to be aware of that supermarket server. Lastly, it's going to configure the user's workstation to have it use the newly spun up Chef server whenever they need to use the functions of a Chef server. And it's also going to configure it to use Supermarket whenever the user of this workstation wants to share or download cookbooks. And that's the end of this config. So the whole point of me running this config was that I work on the supermarket product primarily at Chef, and I wanted a complete development cluster or testing cluster for testing new features of supermarket. So let's pose a hypothetical. And let's say that our company says that we are using too many AWS security groups in our virtual private cloud. So the default limit is 500 security groups per AWS VPC. And yes, you can increase that limit by requesting it from AWS, but again, for the sake of the example, let's say our company does not want to increase that limit. So in order to cut down on the number of security groups we use, we need to alter this config to only spin up one security group with those 2 rules in it, rather than 2 security groups with 1 rule each. So now that we know why we need to refactor, let's go over how we would refactor this config. Now there are 2 common approaches defined in the book Working Effectively with Legacy Code. And the first is what is called edit and pray. This involves making a change, often a major change, deploying it to production, and just hoping and praying that it works. I've heard this referred to as PDD, or prayer-driven development. And the second, which is harder but much more effective and I find much less risky, is cover and modify. And cover and modify involves covering the code with automated tests and then making changes. So last year, I gave a talk on refactoring infrastructure code where I also demonstrated this cover and modify approach. Now during Q&A, someone grabbed the microphone and said, and I quote, "This is a bad approach. You should just look at the code, look at the old code, and write the new code." Now my reaction to that was that I don't have that much faith in myself. In fact, I don't have that much faith in anyone to make changes cowboy style and have it not break anything. And this is because confidence in code without tests is false confidence. I don't trust a human, least of all myself, to know all the ins and outs of how my code works, particularly if it's code I myself did not write, or even when it is code I did write but haven't looked at in a few months. There's also the thing to consider is that there might be bugs in my code, but other parts of my code might be dependent on those bugs in some sort of weird way. So what the code is intended to do by the person who wrote the code is much less important than what that code actually does. The only way to know what my code actually does is to actually execute it as code. That is the ultimate source of truth. And the beauty of adding automated tests is that they will allow me to execute my code automatically. Now, sometimes when I present this approach, people immediately dismiss it as being impractical. After all, if they have a giant legacy code mess, how in the world are they supposed to get the whole thing covered with tests? Are they supposed to suspend new work until they can add tests for everything in the code base? The answer to this is unequivocally no. Even if it were possible to cover an entire code base with tests in the way that was written without tests, it's very impractical to try to cover the whole thing all at once. The goal of adding tests when refactoring is 1, to not make things worse, to preserve what functionality is already there, and 2, to start making the code better here and now, to try to avoid getting back into this wallowing in this legacy code mess in the future. So that brings us to the question, how can we test Terraform? And to do this, we're going to use 3 open source tools. Now the first is Test Kitchen. How many people here have ever used Test Kitchen? All right, we got quite a few hands up. That's good to see. So Test Kitchen is a delightful tool that allows us to spin up a VM or container, configure it with our Terraform config, and then run tests on it to verify whether our code did what we expected it to do. Now you can find out more about Test Kitchen at kitchen.ci. And Test Kitchen works great with Chef cookbooks, Puppet manifests, Ansible playbooks, and more. Now, in order to use it with Terraform, we need to use a special provisioner called kitchen-terraform. Kitchen-terraform comes from the company called New Context, and it was only released within the last month. We need this provisioner to not only be able to provision new AWS EC2 instances with Terraform, but also to be able to SSH into those instances and run the tests we will define in just a little bit. You can check it out at github.com/new contact/kitchen-terraform. In its first release, it does not work with Terraform 0.7, but there's a new release that's just about to be released, I think this week, which I think adds that functionality in. Now we need to configure both test kitchen and kitchen terraform through the .kitchen.yaml file in our configurations code repository. And in this file, we first configure the driver. This defines where we want our instances to be spun up in. Now in this case, we're saying we want them to be spun up through Terraform. And then the Terraform config will define what cloud we're going to spin those instances up in. It's delegating that responsibility of knowing what cloud to spin it up in to Terraform. Now, the next thing we need to do is define the provisioner. This is what will actually create the instances, what will provision our test instances through our Terraform config. And this is conveniently also called Terraform. Now, we also need to be able to tell that provisioner which file contains the value for the variables our Terraform config uses. And remember, in the case of this Terraform config, we're defining them in a file called terraform.tfvars. In order for kitchen terraform to be able to run tests on our instances, it needs to be able to SSH into them. In order to SSH into them, it needs an SSH key. So this is where we define where our SSH key is that can be used to SSH into those AWS EC2 instances. We give it the path to where we keep it on our workstation. And then the additional code here is test kitchen boilerplate. If you'd like to learn more about it, head on over to kitchen.ci. So now that we have our framework for running our tests, what we're going to use to actually write our tests is called inspec. It's a testing language. You can find out more about it at chef.io/inspec. So now that we have our tools to run our tests, let's first start from a clean slate with our code and figure out the bare minimum we need right now in order for our tests to run. So what I like to do when I'm refactoring a Terraform config is I start out by commenting out the entire thing. And then I rebuild it piece by piece, adding tests along the way. So here we've commented out our supermarket cluster.tf. And at this point, if I ran Terraform apply from my workstation, it would do nothing. In fact, it would probably just return an error. So this is, obviously we can't create our test infrastructure just yet. And the first thing we need is our Terraform provisioner. In this case, it's Amazon Web Services. So let's head on back into our Terraform config, and let's uncomment out that AWS provider stanza, this resource. This is one of those bare minimum pieces we need to just be able to write our tests. Now we need to use that provisioner to spin up actual AWS EC2 instances, including both our Chef server. So let's look at our Chef server resource in our Terraform config. As we can see, we're spinning up an AWS instance. We're passing in an AMI, instance type, key name, etc., defined in our variables file. And then we're assigning it to 2 security groups. So let's go ahead and uncomment this. And then at this point, if I ran Terraform apply from my workstation, I would expect it to spin up 1 EC2 instance to act as a Chef server. And I'd like to take a quick moment here. If you're wondering why I'm trying to spin up an instance without having a security group uncommented in the Terraform config, we'll get there in just a moment. So now I need to spin up my second EC2 instance, which is that supermarket server. So going in here, it looks pretty similar to my Chef server resource, and I'm going to go ahead and uncomment it. So at this point, when I run Terraform apply from my workstation, I expect it to spin up those 2 EC2 instances, one to be my Chef server and one to be my supermarket server. And in order to spin up EC2 instances, AWS requires us to provide at least 1 security group. Now we could use the default security group in our AWS account, but that is out of the control of this config. It would be easy for someone unknowingly to change that and have it start breaking our tests because the security group is no longer what we expect it to be. So I prefer to define my security groups in the code so I can be sure they're exactly what I expect them to be. So let's go ahead and head to that section of the config, the section for our security groups. And let's first uncomment out that first security group. That's the allow SSH security group. So this will fire when we run this config. So at this point, if we run Terraform apply from our workstation, it will create that security group and those 2 EC2 instances. Now there's one final piece we need before we can spin up our test infrastructure. remember that kitchen-terraform needs to be able to SSH into our instances, and that port 22 is not open by default. So we need to add a security group rule to that allow SSH security group to allow that SSH traffic in. So let's head on back to that security group portion of our config, and let's uncomment out this security group rule. This allows ingress traffic on port 22. So at this point, if we ran terraform apply, we'd expect to see our 2 EC2 instances, our security group rule, and a rule attached to that security group. So now let's go ahead and create our test cluster. This should be the bare minimum we need just to be able to run tests. So we go ahead and do this by running the command kitchen converge. It got really dark in here all of a sudden by having that black on that screen. Wow. This command provisions the AWS resources through our Terraform config. And it's kind of like running Terraform apply, but it does it from within the Test Kitchen framework and gives us all that Test Kitchen functionality for testing those instances. Now, the first time I run this, I'm going to get an error from Test Kitchen that tells us to view the log file at .kitchen/log/kitchen.log. So I'm going to go ahead and open up that file, see if it gives me any clues as to what's going wrong. And it draws my eye to this line, unknown resource AWS security group.allow egress referenced. It looks like we are telling our EC2 resources to use a security group that we're not actually creating yet. So we need our EC2 instances, both the one for the chef server and the one for the supermarket server, to only reference one security group, since our config only creates one with what we've uncommented out. So let's head on back to our chef server resource, and let's take a look at the line where it's assigned to those security groups. So we're going to say that we need to condense this from using those 2 security groups to using just the one we have defined in our config at this point. And now we need to do the same thing in the supermarket server. So let's head on over into that resource, and we're going to condense it from using those 2 security groups to using just one security group. So let's run kitchen converge again, and just so you know, kitchen converge usually takes a pretty long time to run, so we're going to consider this the magic of presentations, and we're going to have it return automatically. And this time it converged successfully. So at this point, we have an actual test infrastructure, those 2 EC2 instances with that security group and that security group rule. So now that we have an infrastructure we can run tests on, let's actually write those tests. And let's first define a test group in our .kitchen.yaml. Kitchen-terraform needs a test group in order to know what test to run. So heading on in there, back into our .kitchen.yaml file, I first need to define the verifier. This is what's going to be used to run my tests. And then I need to define a test group. In this case, I'm going to call my test group the default group. And then I need to add a test files that I expect to run with this group. So in this case, my test file is security groups. And we'll create this file in just a moment. But for now, let's skip the hostnames attribute, and let's head on over to this username attribute. This is the username kitchen-terraform will use to SSH into our instances. Remember, if we create an Ubuntu instance on AWS, the default username to SSH into that instance will be Ubuntu, and we have to provide it here. If I were to use something like AWS Linux, I would have to provide AWS EC2 user, I think it is, in order to be able to SSH into those instances. So now let's go back to this hostnames variable. This is the output variable we will use to capture the hostnames of our 2 AWS EC2 instances. We need to know their hostnames in order to SSH into them with that Ubuntu username. So in order to use that output variable, we first need to create it. And in Terraform, we do this through the file outputs.tf. So the first thing I'm going to do is define the name of my output variable. I'm calling it AWS hostnames. And this is where our Terraform config will capture information to be used after our config runs. So after I define the name of my output variable, I'm going to define the value. And in this case, I'm defining it as a string, and that string will include the public DNS of our chef server, then a comma, and then the public DNS of our supermarket server. So these are the host names that kitchen-terraform will SSH into them. And we've got the public domain of the supermarket server too. And so let's look at this visually for a moment to understand how this output.tf will work. So when we run our Terraform config from our workstation, it's first going to spin up those AWS EC2 resources we defined. Then it's going to capture the public DNS names of both of those EC2 instances in that AWS hostnames variable. Then it's going to pass that variable to kitchen-terraform, and then it's going to use it to SSH into those two EC2 instances. And then it's going to run the tests on those instances after it SSH, or I don't know what SSH is, but after it SSHs into it. So after adding in the output file, we're going to go ahead and start from a clean slate with our test infrastructure and run kitchen destroy. Then we'll run kitchen converge again to recreate that test infrastructure. And this time, it will create all those AWS resources, but it will also populate that AWS hostnames variable. And it's often good to start out by writing tests just for the area of code that I want to change. So remember, we're condensing from using 2 security groups to using 1 security group. So this area of the code is for our second AWS security group. Remember, we already have 1 defined that allow SSH1. So before we uncomment this, our second AWS security group, let's write a test for this security group. And to do that, we're going to create the file securitygroupspec.rb. Now, if we were to SSH into this instance, which kitchen-terraform is going to do for us, we're going to define our inspect test to say that it should run the command ping google.com. This will ensure that it's able to reach out to the outside internet. Remember, that's the purpose of the second EC2, or the second AWS security group. So let's tell our test to run this command on our instances when it SSHs into them, and state that the standard output of that command should match 1 package transmitted and 1 packet received. If we receive this output from that command, it means that our instances can successfully reach out to the public internet. So let's run this test using the kitchen verify command. And the first time I run this, it's going to fail. It did not get output that matched that 1 package transmitted, 1 received. It was able to transmit 1, but it didn't receive any back. So this means it cannot send that traffic out to the public internet. And this is good. This means that our test should fail when we expect it to. So if we ever break this functionality in the future, our test will let us know that it's broken. So now the next step that we have a failing test is to go ahead and make it pass with our configuration code. So looking back at the config, let's go ahead and uncomment out that allow egress security group and that allow out security group rule. So at this point, people are taking pictures, so I'm going to pause for just a second. So at this point, if I were to run Terraform apply, it would spin up 2 security groups, add that security group rule to each of the respective security group rules to each of those security groups, and those 2 EC2 instances. So remember, in order to use a security group, we need to assign it in our EC2 resources. And we took out that second security group when we were first just getting our test infrastructure working. So let's go back to the resource that defines our chef server, and let's change it from only assigning it to 1 security group to assigning it to both those security groups we now have uncommented out. When you're refactoring code and you're adding tests, you're going to do a lot of changing that code back and forth. And now we need to do this in our supermarket server as well. So let's head on back to our supermarket server resource, change it from assigning it to just that 1 security group to assigning it to that allow out security group as well. So again, we're going to start with fresh test infrastructure running kitchen destroy, then create new infrastructure running kitchen converge, then kitchen verify to run our tests, and this time the output shows that my test passed. And because it passes, we know that area of the code, we can change it without breaking current functionality. We can now safely make a change. If it breaks, we'll know about it. So let's go ahead and condense those 2 security groups down into 1 security group in our Terraform config. And to do that, let's head on back to where that second security group is, that allow egress security group, and let's delete it, and then change this line for that allow out security group rule from assigning it to the allow egress security group, which no longer exists, to assigning it to the allow SSH security group. Now we might change the name of the security group to reflect that it does not just have allow SSH rules now, it also has allow egress rules. But for the sake of time, let's go ahead and leave it as it is for right now. So now let's make sure it works by changing our chef server and supermarket resources back to using only the one security group. So heading on into our chef server resource, let's change it from using those 2 security groups to using just 1. Then head on over into our supermarket server resource. Again, change it from using those 2 security groups to using the only one in our config now. And at this point, if I ran Terraform apply, I would expect it to spin up only 1 security group and assign it both of those security group rules, spin up both those EC2 instances, and assign them to that 1 security group. So let's go ahead and destroy our current test infrastructure to give us a fresh slate to work on, then run kitchen converge, then run kitchen verify to run our tests, and the output will show that my test still passes. So at this point, we have changed the functionality of our code. We have changed our code. We have condensed it to using 1 security group without breaking the current functionality we had covered by tests. So now let's not stop here. Now that we have a test harness in place, let's improve the design of this code to make it easier to work with both now and in the future. And we're going to do that by moving our security group code out into its own module. And the benefits of having your Terraform config in modules is 1, it's a self-contained package. 2, it's a reusable component. We could potentially use it in other Terraform configs that need these same security groups. And 3, it's a great way of improving the organization of our code. It makes it easier to find out what we need when we need it, and to fix what we need when we need to, and to fix only what we intend to when we intend to. So let's again run kitchen destroy to give us fresh infrastructure. And at this point, I'm going to go ahead and create my module. And for this example, I'm going to create it as a directory within my config codes directory. So I'm going to go ahead and make the directory security groups, and then create a main config file for it, which I'm going to go ahead and call main.tf. So once we create this file, we're going to copy and paste the security groups code from that supermarket cluster.tf into this main.tf file. And now that we have this code in its own module, we need to be able to connect to and use the module from our supermarket cluster config file. And this is often the trickiest part of refactoring Terraform code into modules, figuring out how to connect to it. So the first thing we need in order to wire them together, we need to know what variables we need to pass from the supermarket cluster config into the module's config. So let's take a look at the module's new main config and check out what variables it uses. So whenever I see a variable like this that starts with the var prefix, that means it needs to be passed into the module from outside the module. So we definitely need to pass this one, var.username. And I quickly want to give out a shout out to Nihil Veze. It was his presentation at last year's HashiConf that taught me the trick of passing the username of the person running the Terraform config into the name of AWS resources that I spin up with Terraform. This makes it a lot easier to, 1, know who spun up what or who's running up the AWS bill. And 2, it avoids namespace collisions. Before I did this in my security groups, I would often spin it up, then try to spin up my Terraform config again, and it would return an error saying there's already a security group with that name existing. So thank you again to Nihil. And now let's move a little further down the config and take a look at this value. This one refers to a resource within the module's config. It will be determined when that AWS security group resource is provisioned within our module. So since this value is coming from within the module, when I practiced this talk, someone told me this would be a great time to make a joke. The value is coming from inside the module, like the call is coming from inside the house. It does not need to be passed in from outside the module. So let's change my slides. There we go. Let's visualize this for a moment. We start off with our supermarket cluster config, which uses variables that we define in our variables.tf file, and we define the values for those variables in terraform.tf vars. And then within our module, we also need to have a variables file. So let's go ahead and create this file. This will define the variables our module's config uses. And this is what that file looks like. We've got our variables.tf file within our modules directory at this point, and we just define the username variable. So that variable is going to be used by the main.tf config. So effectively, we're passing these variables from within our supermarket cluster.tf, our main config, into the module's config file. And this is how we would use that module from within our supermarket cluster.tf. We first define the source for the module, which in this case is that subdirectory within our codes repo. And then we define the value for that variable that we're going to be passing that module. So we say we're going to use whatever username is defined in our terraform.tf vars file and pass that into the module to use. So let's go ahead and run kitchen converge to converge these changes on our test infrastructure. And the first time I run this, I'm going to get an error that the converge fails. So I'm really glad I tested this before I deployed it to my production infrastructure. So let's look at that file .kitchen/log/default-ubuntu.log and look at the details of why this converge failed. So taking a look at this file, it looks like our AWS instance resources are trying to access the AWS security group resource, but no longer can since that resource now lives within a module. So now we need a way to pass the name of the security group we create in that module back into our supermarket cluster.tf. And we do this through defining that outputs.tf file from within the module. So this is what that output will look like. We define that we will output a variable named sgname for security group name, not Stargate name. And the value of that variable is a string that includes the name of the security group spun up by that allow SSH security group resource from within the config. So now that we've defined that output variable, we need to use it from within that supermarket cluster.tf config. And to do that, we're going to head on back into our chef server resource, change it from using that security group, which is now defined within a module, to using the output variable, module.securitygroups.sgname. Then we're going to head on into our supermarket server and do the exact same thing. We're going to change it from using that to using our module.securitygroups.sgname. So at this point, now I'll go ahead and save these changes, run kitchen converge to try and spin up my test infrastructure again, then run kitchen verify to run those tests, and my test passes. So we have just improved our resource usage, only creating one security group rather than two, and improved the code's organization and design, moving the security codes group out of supermarket cluster config and into the module, and we've done this with minimal risk. We can feel confident deploying this code that at least the security group's part is working correctly. So what I hope I have shown you in this talk is that infrastructure code must be maintained and refactored just like application code. And even more so because infrastructure code involves so many moving pieces. So when refactoring, always cover your code with tests first and refactor it one small piece at a time. Thank you.